Hello, gentles and ladymen. I'm Spiro, and I'm not a wizard. In this episode, this is going to be part 2 of my tutorial on how to print Hello World using Commodore 64 assembler. So in the first video, we got to this point here where we had discovered that there are different character sets that the Commodore 64 displays. So this is the word hello in character set 2, and this is the word world in character set 1. There is a shortcut on the C64s to switch between character sets, and that is Shift and the Commodore key. So if I do that on Vice, you can see, that we shift into character set 2, which most, all the aka lowercase mode. So those funny characters that we saw before are now displaying as uppercase characters in character set 2. So this PDF that I pointed to earlier from slark.me/c64, so this shows character set character set 1 in that column, so that indicates that that's character set 1. That's what is going to be displayed if you're in character set 1 mode, and the darker is what's going to be displayed if you're in character set 2, so it'll be lowercase a. So hence why the normal characters that get displayed in the basic screen are in uppercase, because by default you're in character set 1. So when I press Shift Commodore and switched into character set 2, the default text became lowercase. So if I go back, Shift Commodore, we go back into character set 1. Now, it's a little bit interesting because there's also the characters that get displayed here on the basic screen. If we scroll down, we also find, so this starts at the A is at address hex, is character 01 in hex. If we go down here, we find we've got at 41 hex, you'll see an uppercase A. So this continues from here, right? So again, if you just remember that first column is character set 1. So in character set 1, by default on the Commodore, when you press Shift and a letter, you'll get these characters, which is why when we when we load stuff off a disk, for example, you'll see people type in load, or if they're typing out a basic listing, they'll print list. But there's a shortcut of L Shift I, and if you press Shift I, you'll get that funny what looks like the top right corner of a border. So if we go down here to I, you'll see that's that character there. So these are the shifted characters. So in character set 1, if you press Shift I, you'll get that. If you press Shift A, you'll get that heart symbol. Okay, so if we go Shift A, we get the heart symbol. So B, C, D, E, F, and so on. So you can see that they match those. Now, that's also why. So that's why these characters came out funny in our assembly program because I had switched the word hello into these hex numbers 4-1 and onward, whereas world was using the unshifted characters starting at 01. So if we now switch to back to character set 2, you'll see that these are shifted characters and these are shifted characters. So we'll go Shift Commodore, and you'll now see that I had the lowercase l and the capital I, because that was the Shift I that we pressed for the list command. And then I held down Shift and pressed A, B, C, D, E, F. So that gave us the uppercase characters, the shifted characters. So we can exploit that in our program. So we know that by default the Commodore is in character set 1, and that we have got these shifted characters available to us. Now you'll also see here on this PDF you've got a bunch of control codes. We can enable reverse on characters. We can actually switch to character set 2 from a basic print statement. So by printing out, I can go, so I'll print hello. I'll switch back to the main character set. That shouldn't matter, but when we're printing, we can also actually add in some of these control commands into a basic print statement. Okay, so we can go back up here, and if I press insert, so I can insert another character. If I want that to be printed in reverse, I can press Control R, and you'll see that it should show up. If the basic interpreter here recognizes that I've got the double quotes, so it knows now that it's if I press Control R, it's going to display this character within a string. So if I go Control R, you can now see we've got the reversed R just like that, and we've got hello. If I press enter now, it prints hello again, but reversed. Notice it was only for that string, so it set it back. It unreversed the text for us at the end of that. If we were to do that in assembly, we would have to manually unreverse the text. We'll get onto that in a bit. Some other interesting things to note. So with basic, we can also, there's also a, so if we do a print, so question mark is the shortcut for print. If we print, sorry, I'm not going to do that. If we print these numbers using the CHR string function, we can, so if we want to, if we put character string 7, we'll get a G returned back on the screen, printed on the screen. And that failed. Why did that fail? Should we have gotten a G? Oh, we should have gotten a G. Let's add insert there. What happens if we print 71? Now we get a G. Why is that? It is printing the shifted character. I don't actually know why that is. As I said, I'm not a wizard. I'm new to some of this. and I'm not going to edit the video out, you know, you can be here with my mistakes. I expected that to have printed out the G. I don't know why that didn't. Okay, so there's another interesting thing about the Commodore BASIC. I wonder if that is... So what I was going to get into in this video was there's another way of printing stuff to the screen, which is using a ROM kernel function in assembly, and that was going to use the different character set. So I wonder if, and please chime in if you know more about the C64s than I do, which isn't hard. Character string must be using the same function or the same way to display stuff on the screen as the ROM kernel, what's it called, the print character function, which is FFD2. I'm jumping ahead of myself for those who don't know what that means, but there are some quirks in how stuff gets displayed on the screen. We can, for example, we can print color changes, or we can directly do, so if I pressed Control 2, which we can see here is change character color to white. If I press it just in the normal interpreter, if I press Control 2, you'll see my cursor color goes white, and I'm now printing in white. The other way of, and if I press Control 8, we go to yellow. So if you do that after a quote, so if I now press Control 2, it's going to display that character in the string. So if I now do hello, it will print that in white. It's actually changed the character set color to white, which is interesting as opposed to the reverse, which resets itself. I'm not sure why that is. I don't know enough. But what I did want to point out here with BASIC is that there are a lot of different ways of switching between character sets, checking what character set you're in, and getting different outputs and different characters by being in different character sets. There's actually there's a few ways of doing it. So that you may know about peek and poke commands, which are peeking into memory locations or poking numbers into memory locations. Another quirk of C64s is that I don't know how to use the peek command directly. I only know that you can assign it to a variable. So if we peek an address of 53272, when we print the result, that peek that came out of memory, we have got a 21. Now that tells us that we are in character set 1. I don't know what the 21 refers to, but what I do know is that if it was 23, we would be in character set 2. If it's 21, we're in character set 1. So we can actually poke 53272 and put it into character set 2 by changing that number to 23. Why did that have a syntax error? Sometimes you use these and sometimes you don't. There we go. Okay, there we go. Sometimes I fail at life. So we're now in character set 2. And if we change that, if we poke that back to 21, we're going to go back to character set 1. And that basically does the exact same as if we were to press Shift Commodore, Shift Commodore. There are, I can see here, there are ways to disable that Commodore Shift and re-enable it. So I guess it's possible that there are games that or programs that disable that ability so that they can display things as intended. And I get that would be pretty important with if you're displaying PET-ski graphics. You know, you don't want someone to shift it and make it look like all text as opposed to the pretty graphics you've put all that hard work into. So that, I think there was another memory address that you could do that to as well. Anyway, we've found that there are some interesting quirks of how the character sets are displayed. So if we go back into our cartridge freeze, press escape, go back into our machine language monitor, we do a memory dump of the text that we had, so the hello world. We can now identify that we've got the world is characters 17. So in the initial range, so those are hex now, we've gone back to hex from decimal. So 17 is basically the 0, 1 through to 1A are the standard Commodore Basic screen characters, unshifted. The 4, 1 through to 5A are the shifted characters. So hello is in shifted characters, world is in unshifted characters. Now that works when we were printing out 2, or what the, that works because we were using the STA command, so to directly store a character onto screen memory in the basic screen. So there is another function. So the Commodore 64 Kernel ROM has got built into it this functionality. So the ability to the basic interpreter, the basic operating system functionality, the code that tells the c64 how to read and write to different devices like floppy drives, tape drives, how to talk to the screen, the actual physical monitor. All these things are code on the physical hardware ROM. Now these days we have got operating systems that are all software based, and the extra functionality that programmers use to talk to the operating system and to the user are done through libraries. So we call them software libraries, APIs, application programming interfaces, but they're all software based these days. So in the Windows world, you'll have DLL files, which are dynamically linked libraries. And in the Linux world, you will have library files that are either statically linked or dynamically available. And those library, like if you write a program, you will say, when you compile the program, you'll say, I need access, I need to compile in this library, and this library, because the commands I'm typing in are functions that are only available in those libraries. So similarly, the Commodore 64 had a rudimentary set of functions, and one of them was called CHR out, for character out. Now we can't refer to character out by name because the 8-bit computers were not that advanced. In an assembly program, you could set that up as a variable effectively, but that character out function is at address FFD2, and I really hope I remembered that address correctly because none of this that I do is scripted. And so and that's a subroutine. So if you use the JSR command, the jump subroutine, then it will expect that you will have passed something into the A register, the accumulator, and whatever is in the accumulator, it will pass to this function, and it will display that on the screen. But it will display it on the screen in a different way to storing it directly to screen memory. Just like when we did the print with the character string and we tried to print character string 7, nothing came up. But when we used 71, that came up. So the FFD2 is using a different set of characters to display on the screen than the normal basic. We'll figure that out in a sec. I'm not 100% sure if it's the 6 or the 4, the 6.1 or the 4.1 based characters. I think it's... We'll get to that. I'm learning as well. So what we want to do is we want to change our code to use that FFD2 instead of this STA function, STA opcode. So what I'm going to do is, and the other difference is that we're not going to need the offset because the character out function subroutine is going to display the character at the next available screen location. So it's instead of, so whereas the STA command is putting it at a location that you specify on the screen, the character out function is basically like typing in something at a command line if you're in DOS or Linux or whatever, and you type in something and it'll just come up on the next line available. Or like the print statement in the Commodore 64 where it will just print it on the next available line. So what we'll do is we'll go to this and we'll assemble this address, and that is 3 bytes long, so the new command should hopefully only be 3 bytes long. And what we're going to do is we're going to jump to subroutine FFD2, clear that out because we don't need the offset, We do still need the offset for figuring out, for reading in the character, but not for displaying it to the screen. Press return on that. That was 3 bytes, very good, so it didn't ruin our program. So let us clear the screen, dump 1000 to 100F. Oh, sorry, end of our program is 100E. And so the rest of our program is intact. So just a quick refresher from the last video, we're going to load number 0 into the X index register. We're going to load the address of the first character at memory location 1030, offset by X. So the first time around it will be 1030. If that character is a 0, then it will jump to memory location 100E, which is our return from subroutine, which will quit the program, because in this case what we're returning to is basic. Otherwise it'll jump to the subroutine and print the character to the screen, increase our counter, and then jump back to load the next character onto the screen. However, we've found out that we can't print these lower characters. So what I'm going to do is I'm going to change them all to these shifted characters. So we've done that for hello. What we need to do is do that for world. And if we remember, we had 17 for W and 57 is our shifted version. So that's going to be 57. That's going to be probably 4F for the O. Yep, 4F. Press enter on that. So that's going to be 52, 4C, 44, and we're leaving that full stop as is. We'll see what happens with that. I'll press enter on that. So let's redo that. So now that shows different characters. So as far as I know, what we should get should match that back in basic. So another quick refresher, we're going to jump in basic to memory location hex 1000, but because basic only works in decimal, we're going to need the decimal version of that, which is 4096. So let's exit back to basic, 7 to resume from Super Snapshot. So whereas previously we got it to print at the top of the screen, this time it will just print on the next line after our command. So we're going to go sys 4096, which will cause basic to jump to our program and start executing it. So we should get hello world printed out with the full stop as well. Great. So when we stored it directly, we had to use these characters, and it was using character set 1, which was this column. But when we're calling it through the Kernel ROM function, it uses this set, but character set 2. I don't know why that is yet. This is part of my journey for the learning and the understanding, but they work differently. So it means that depending on how you're going to write your assembly program and how you're going to be displaying stuff on the screen means you're going to be having to use the different the different hex codes. So as my expectation now is if I switch to so basic is in character set 1, however our assembly program has printed what looks to be the characters from character set 2. So my expectation is that if I press Shift Commodore to go to set basic to character set 2, those should change to these funny characters. Let's see how that turns out. Wow, that's interesting. So it didn't, it gave us lowercase. So it's actually using these PETSCII codes. Isn't that interesting? So that would mean that is why the full stop printed, because the PETSCII code for full stop was the same. Yeah. If we shift to, let's go back to character set 1. Let's go back to our cartridge, M4 monitor. Let's dump out our memory locations. Now we were talking about these here, hex 6.1 through to hex 7A. So let's change the characters to those 6, 6, 6, 6, 6. Be interesting to see what happens to that space. That should stay the same. That should be a 7. That should be a 6. Press enter on there. 7, 6, 6. Space. Sorry, the full stop will stay the same, and we've got our 0 byte to end it. Press enter to lock that in. Reload that. So we should now have, because we're in, if we run the program now, oops, that window. If we run the program now in BASIC, we should be printing, and if we're in character set 1, those characters, and if we shift to character set 2, it should print those characters. So let's resume, go back to BASIC. Sys 4096, we're in character set 1, and now we're in character set 2. So let's try character set 1, and we should get hello world looking funny. We get hello world looking funny. If we now switch to character set 2 by either pressing Shift Commodore, we get it looking normal. Or poking that. So it's an interesting thing to keep in mind. There is another excuse me, there's another kernel ROM function which reads keys, and that is FFE4, I think, from memory, and that will read a key, and the keys that it reads, I think, are from this range. It'll be worth playing around with. it's kind of interesting. Oh, I've got to be in the right window. So I think that's the long, convoluted way of showing you how the Commodore 64 prints stuff to the screen and using assembly language. I know it's been very long, and I haven't scripted these. I'm not very good at scripting videos, so I kind of fly blind. I hope that's okay. As I say, I'm learning, but as I was learning, I was finding there were a lot of tutorials out there which didn't really go into enough depth. A lot of them are type in these commands and this will happen, and play with it by changing some numbers or some values or some strings of text. And I don't think that taught enough of the fundamentals for people to really understand what was going on. And these videos kind of will go over how I approach things and how I do my investigation and how I try and understand how things work. As I said, as you saw, some of this was me learning as well. Like, oh, excuse me. And you know, it's quite interesting. I do like trying to figure this stuff out. And if I can help you understand things better and give you an understanding of my thought processes when I'm going through these, and that helps you, then I'm happy with that. You know, as I say, I'm new to the Commodore 64. I never had one growing up. I'd used them a few times. I've done other assembly language, and so that's kind of helped me understand things a little better, and it's also helped me kind of identify the lack in other tutorials. So what I would recommend, if this is interesting to you, obviously if you've come this far through the video, then it probably is interesting to you, and if you're still awake, then you know, by all means continue to play with this stuff, but play with it. Not, like I see a lot of people saying they want to learn assembly language and they discount BASIC. On the Commodore 64, BASIC is integral to the system. You can't avoid that. But I think even if you don't want to learn BASIC, you can still use it to prove things much easier and much faster than you can in assembly, and to help you understand things. Like when I tried to print character string 7, I didn't know why that wasn't happening, but it's a much quicker way of doing discovery. So what I would say is a great thing to play with is, I mean, this PD file is fantastic on so many levels, that it also shows you these control codes, and and as I said, the difference between what shows up after you press the quotes. If I press Control R after I press the quotes, I get that character. But if I press Control R without the quotes, I was expecting to get reverse text. See, it's another thing. I don't understand why some things work, some things don't. The color code changes. If I go Control 8, maybe it's because it remembered that I had the quote on the line. Let's go try that again. Control 8. There we go. I've changed to yellow. Now if I press Control R, there we go. Now I type this is reversed. There we go. So there are some interesting quirks in how the c64 works, but if you use this, you can use these control codes in a string of text, even from an assembly program, to make things look a little different on the screen. And if you go through a lot of these, they do show you some cool other functionality. There are stuff. There's more stuff down here, more color changing. There's more switching to character sets, like I have not been able to get. Let's try that switch to. So let's go to character set 1 by pressing Shift Commodore. And this apparently, if I do a Control 9 or a Shift N, I know the Shift N. Well, let's find out. Let's go print quote Shift N. No, that just gives me a capital N. So if I go Control 9, see, that gives me a different character. If I could have gotten it to print that reverse /, then I think that would have been the same as poking 21 into that address, which would have been to switch basic into the different character set. I haven't figured out how to do that through a print statement. As if I go blah 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 blah, it's going to print blah 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 in reverse, which is weird because the reverse is a different code. Control R. But I press Control 9. I don't know why that is. Yeah. I think, I'm pretty sure, if I remember rightly, if I print character string 142, print character string 142, that's another way of switching character sets. There we go, bam. To switch back to character set 2 was 14 up here. So if I go back up here, change that to character string 14, we go back into character set 2. So there's a lot of ways to fiddle with what's on the screen. So play with this, and you'll learn a lot. Like, you will learn a lot. I'm going to stop rambling. I think I've tried to say the same thing several times now. How long are we? It's another almost 45-minute video, so I think I'm going to call that one here. I've given you two 45-minute videos on how to print Hello World to the screen with a Commodore 64, which is probably TMI. And if you haven't fallen asleep, thanks for sticking by. And let me know in the comments what you think. Is there something else you want to see? Is there... I might do something on reading characters in, as opposed to doing the... if I'm going to type in the right screen. Like in BASIC, where you go into some text, and we put that into a string. Illegal direct error. Really? Oh, can't you do input from the direct? You can only do it in a program. Wow. So that command is telling me illegal direct error. I can't run the input command from BASIC. I've got to go 10 input and then go run. Huh. Well then. There we go. So in assembly programs, we are going to use actually the equivalent, I think it's get string in BASIC. I can't remember the basic command, but there is a command that in basic that gets one character at a time, and we will use that same function in assembly, and I'll do a video at some point soon on how to read characters in from the keyboard in assembly, and we will be able to use that to print them back out to the screen. And that is that for this video. Thanks for watching, and I hope you enjoyed it. Let me know your thoughts down below. If you are a C64 guru and a lot of this was you've identified a lot of errors which I have bound to have made, or some misunderstandings I may have made, there's bound to have been plenty of those. Please let me know in the comments. I have welcomed that. I want to learn more. My goal with this is to educate people a bit better, but the goal with my channel has been to learn more about C64 programming, and what I'd like to do is create a text adventure game written in assembly. Go back to my first video on the channel, which was going through a book on adventure game programming in BASIC, and that was quite good from teaching me the structure of how to write a game, a text adventure game. You know, not knowing how to structure the data, how to read in the data. It was quite interesting. Excuse me, if you haven't seen that, go check it out. So that's my goal. So I'm trying to learn more about the 6502 or C64 assembly so that I can write my game in that. Yeah. Okay, I'm going to stop talking now. This time for reals. See you later.